This section of trigonometry relates the definitions of the trigonometric ratios to angles of elevation and depression. It is therefore imperative that you are very familiar with all of these concepts. Angles of elevation and depression are measured from the horizontal to the line of vision. Angles of elevation are always looking up, and angles of depression are always looking down. Another thing to note is that the horizontal plane is always perpendicular to the vertical plane. The walls of a building, which are in the vertical plane, are at right angles to the ground, which is in the horizontal plane. The points A, B, C, and D all lie in the same vertical plane, while the points C, E, F, and D all lie in the same horizontal plane. The vertical plane, ABCD, is perpendicular to the horizontal plane, CEFD. This concept is explained in detail in both the workbook and the online courses, the links of which have been provided in the description box below. Andrew stands at the top of an apartment building that is 122 meters high. He notices that the angle of depression to the base of a tower, in the same horizontal plane, is 28 degrees, and the angle of elevation to the top of the tower is 52 degrees. We are required to determine the distance between the building and the tower, and the height of the tower. Before we can start the problem, we will first need to draw a diagram that depicts this information. Firstly, since we are talking about a building and a tower, we will draw two vertical lines, with the tower being taller than the building. We know this, because the problem states an angle of elevation to the top of the tower, which implies that the tower is taller than the building. From Andrew's position in the building, the angle of depression to the foot of the tower is 28 degrees. Andrew is at point A, and the foot of the tower is at point D. The angle of depression, 28 degrees, is measured between the horizontal and AD. The angle of elevation, from where Andrew is standing, to the top of the tower, is 52 degrees. The top of the tower is at point C, so the angle of elevation, which is 52 degrees, is measured between the horizontal and AC. Before we continue, we need to mark the height of the building, which is 122 meters, as well as right angles, between the two vertical planes and the horizontal plane. We are required to determine the distance between the building and the tower, which is the length of BD. Since BD is a side of triangle ABD, which is a right-angled triangle, and we know the length of AB, another side of this triangle, it makes sense to start in this triangle. To use a trigonometric ratio in triangle ABD, we will need to know the size of an acute angle. Angle ADB equals 28 degrees, since it is alternate to angle DAE. Horizontal lines are obviously parallel to each other, which means that alternate angles are equal. In triangle ADB, relative to the angle 28 degrees, AB is the opposite side, and BD is the adjacent side. So, AB over BD equals tan 28. BD is therefore approximately 229.45 meters. If you are unsure about anything we have just done, this is explained in detail in the workbook and the online courses. Since we are only applying trigonometric ratios in right-angled triangles in grade 10, in order to determine the height of the tower, which is the length of CD, we will first extend line segment AE until it meets CD. We now have another two right-angled triangles to work in. The length of CD is therefore the sum of DF and FC. DF is 122 meters, since ABDF is a rectangle, and the opposite sides of a rectangle are equal. Likewise, AF equals 229.45 meters. In triangle ACF, relative to the acute angle, 52 degrees, CF is the opposite side, and AF is the adjacent side. So, CF over AF equals tan 52. CF therefore equals 293.68 meters. The height of the tower, CD, is thus 415.68 meters. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.